When the first reefs appeared, Earth's oceans were nothing like the vibrant ecosystems we know today. The oceans were chemically rich, saturated with calcium, magnesium, and dissolved bicarbonate, while sunlight poured over vast shallow platforms. In this environment, the earliest reef builders were not animals at all but dense microbial mats dominated by cyanobacteria. Their sticky extracellular polymers trapped sediments, layer upon layer, forming stromatolites, the first long-lasting biological structures on the planet. These reefs were not skeletons but accreting mineral towers built slowly by microbes shaping chemistry around them. Oxygen produced in their upper layers created microgradients that encouraged carbonate precipitation, allowing stromatolites to persist and spread across coastlines for nearly 2 billion years. Their success was tied to ocean chemistry, widespread supersaturation of carbonates, low grazing pressure, and stable shallow environments. Over time, rising oxygen altered the oceans. Iron that once buffered oxygen was removed, and carbonate saturation increased, making the oceans more favorable for harder, more mineral-rich structures. As the Proterozoic gave way to the Ediacaran, new organisms began experimenting with biomineralization. Some algae began depositing calcium carbonate within their tissues, creating thin, rigid frameworks. Early sponges formed porous, filter-feeding structures that stabilized sediments. These innovations were the precursors of animal-built reefs. The real breakthrough came in the Cambrian, when organisms first evolved robust skeletons. Archaeocyathids, cup-shaped filter feeders, were the earliest animals to build extensive reefs, forming towering sponge-like frameworks across continental shelves. For the first time, reefs were no longer just microbial surfaces, but three-dimensional habitats built by multicellular organisms. Hard skeletons offered protection, structural height for gathering light or food, and internal ion control in increasingly dynamic seas. These skeletal reefs transformed ecosystems, concentrating biodiversity and reshaping marine food webs. But across Earth's history, reefs repeatedly collapsed during acidification events, anoxic intervals, and mass extinctions. Microbial reefs often returned after each collapse, only for skeletal reef builders to rise again when ocean chemistry stabilized. Even the end Permian catastrophe erased nearly all reefs, forcing life to rebuild them from microbial beginnings. The earliest reefs were chemical worlds shaped by cyanobacteria, later ones were biological architectures shaped by animals. The first long-lasting reefs began when microbes trapped sediments and changed water chemistry long before corals existed.